Welcome back with another video on TryHackMe.com. This is Zahin here, and we are doing container vulnerabilities today. So it will take 60 minutes to do that. Hopefully, in next two videos we'll be able to cover that. In first video, we'll cover task 1, 2, and 3, and probably 4 as well. And in the next video, we'll cover task 5, 6, and 7. I already started my attack box and also the target machine here. So let me add one over here. Okay, so let's get into it. Okay, so introduction, deploy. This room will demonstrate some of the common vulnerabilities found in the Docker containers and how an attacker can abuse these to escape. Learning objective. In this room, you will learn the following: some of the vulnerabilities that can exist in the Docker container, what you as an attacker can gain from exploiting these vulnerabilities, why these vulnerabilities exist, i.e. misconfiguration, how to search for vulnerabilities within a Docker container, prerequisites. Okay, before proceeding, it is strongly recommended that you have completed the intro to Docker room. We already have done so and are comfortable with the Linux CLI. We are somehow comfortable. Important context. This room focuses on exploiting the Docker daemon itself, which often relies on having elevated permissions within the container. In other words, this room assumes that you have already managed to become a root in the container. Deploy the vulnerable machine. For this room, we already done so. Press the green button start. We have done. You can access the machine using the credential below with the TryHackMe attack box or by connecting your machine to TryHackMe network. You will be using this machine to answer the question throughout this task in this room. Sure. So let's log in root at 10.10.22.250. Password is TryHackMe123 and ampersand. We logged in. ID, yes, we are in the root, as you can see here. All right. Complete me to progress with this room. Sure, we have done so. Okay, our streak is 16 now. Awesome. So we are not losing any streak from now on, right? Okay, container vulnerabilities 101. Before we begin, it is important to recap some of the things learned in the intro to containerization room. First, let's recall the containers are isolated and have minimal environment. The picture below depicts the environment of a container. So we have physical computer, just like a hardware. Then we have computer, operating system, Windows, Linux. In this case, mostly it will be Linux. Docker engine exe file that you need to install on top of the operating system as a software, and then you can run your containers. Okay, container 1, 2, 3, and a diagram demonstrates 3 containers on a single computer. Sure. Some important things to note are, just because you have access, a foothold to a container, it does not mean you have access to the host operating system and associated files or other containers. Okay. So even though you have access to the container, you are able to compromise. It does not mean that you can access the host operating system where it is hosted. I mean, you cannot access host operating system unless you make your way from the environment from here and bypass the Docker engine and directly connect to the host. Okay, we'll see that how we can do that. Due to minimal nature of the container, they only have tools specified by the developers. You are unlikely to find fundamental tools such as netcat, wget, and even bash. This makes interacting within a container quite difficult for an attacker. Sure. What sort of vulnerabilities can we expect to find in Docker containers? While Docker containers are designed to isolate applications from one another, they can still be vulnerable. For example, hard-coded password for an application can still be present. If an attacker is able to gain access through a vulnerable web application, for example, they will be able to find these credentials. You can see an example of web application containing hard-coded credentials to a database server in the code snippet below. Right. So here we have database host, which is connected to localhost. That means it is on the local host. Your application and your database is hosted on the same host, okay, or within the same host in a different container maybe. Define DB name sales, database name is production. Okay, and we are saving the password in a clear text without using the environment variable or using the service account to do that. In this case, you don't need to mention the password directly in your any of this code. Okay, this, of course, isn't the only vulnerability that can be exploited in the container. The other potential attack vectors have been listed in the table below. We have vulnerability and description, misconfigured containers. Misconfigured containers will have privileges that are not necessary for the operation of the container. For example, a container running in privileged mode will have access to host operating system, removing the layer of isolation. Okay. So the admin privileged can directly connect through the host operating system, removing the layer of isolation. So we can directly connect here. Okay. All right. Moving forward, vulnerable images. There have been numerous incident of popular Docker images being backdoored to perform malicious actions such as crypto mining. It was wild back there, but now it is minimum now because of the advancement in the technology that we have, and we are able to block a lot of crypto mining scripts now. Network connectivity. A container that is not correctly networked can be exposed to the internet. For example, a database container for a web application should only be accessible to the web application container, not the internet. Additionally, containers can serve to become a method of lateral movement. Once an attacker has access to the container, they may be able to interact with other containers on the host that are not exposed to the network. Okay, so we can laterally move within the network. We'll see how we could do that. This is just a brief summary of some of the types of vulnerabilities that can exist within a container. The task in this room will delve into this further. Okay, so we are already logged into the root access. Let's consider our task 3 here. Vulnerability 1, privileged containers capabilities. Okay. Understanding capabilities. At its fundamental Linux capabilities are root privileges given to processes or executable within the Linux kernel. These privileges allow for the granular assignment of privileges rather than just assigning them all. These capabilities determine that permissions a Docker container has to be the operating system, the operating system. Okay, operating system के ऊपर कौन सी permissions हैं. Docker containers can run in two modes, user, normal mode and privileged mode. In the diagram below, we can see the two different modes in action, the level of access each mode has to the host. A diagram demonstrating the difference of container mode privileges. Okay. Container 1 is normal mode, container 2 is normal mode, container 3 is privileged mode. As you can see here, application 3 environment is computer operating system, and we can directly connect with the host rather than connecting with the Docker engine. So that's why we are bypassing it. Okay. Note now container 1 and 2 are running in a normal user normal mode, whereas container 3 is running in privileged mode. Container in user mode interact with the operating system through the Docker engine. Privileged containers, however, do not do this. Instead, they bypass the Docker engine and directly communicate with operating system. What does this mean for us? Well, if a container is running with privileged access to the operating system, we can effectively execute commands as root on the host. We can use a utility such as capch, which comes with libcap2-bin package to list the capabilities our container has. Okay, let's run this and let's see what we have here. I'm gonna copy paste it. Capch. Woohoo! We have a lot of permissions. Okay, maybe everything is unlocked, and we are part of the group root. That mean we have root privileges. Capabilities are used in the Linux to assign specific permissions to a process. Listing the capabilities of containers is a good way to determine the system's call that can be made and potential mechanism for exploitation. Some capabilities of interest have been provided in the terminal snippet below. Okay. In the example exploit below, we are going to use mount syscall as allowed by the containers capabilities to mount the host controller groups into the container. The code snippet below is based upon but a modified version of proof of concept. Okay, you can click on it and try to read it after completing this room or while completing this room, which details the inner working of this exploit as well. So we have some commands here. We are making some directory. We are mounting some C groups. Okay, here on this directory. Then we are making another directory here. Echo1. Okay, we are doing something. I mean, we are writing one into that folder, and then we are doing something with the host path. I don't know what we are doing here exactly. Echo host path, and then we are moving the host part exploit to the release agent, and then we are trying to populate shell in the exploit, and then we are trying to get the flag and putting it in a flag.txt inside the exploit folder, and then we are changing the ch mode permissions. We can access and execute exploit, and then we are doing something here shc echo, and then we are putting it in a process. I think maybe they will explain something. Okay, explaining the vulnerabilities, they are explaining it here. We need to create a group to use the Linux kernel to write and execute our exploit. Okay, the kernel uses C groups. Yeah, we saw that there is some C group here. To manage processes on the operating system, since we can manage C groups as root on the host, we will mount this to temp cgrp. So this is temp folder, and we are mounting it to cgrp on the container. For our exploit to execute, we will need to tell the container to run our code by adding 1 to temp cgrp x notify. We are telling Kaldan to execute something once the C group finishes. Okay. Notify on release. Okay, so once we put 1 here, so that means we will execute something once the C group is finished. We find out where the container files are stored on the host and store it as a variable. So we are storing it as a variable. So this is the command to find where the container is stored on the host machine, and we are creating it as a variable. 4 is we then echo the location of the containers file into exploit. Okay, and then ultimately to the release agent, which is what will be executed by the C group once it is released. Okay, this is understandable. Let's turn our exploit into a shell on the host. Yeah. Okay, this is what we have to do, I think. Execute a command to echo the host flag into the file name flag.txt in the container once the exploit is executed. Okay, make our exploit executable. Okay, we create a process and store that into this directory. When the process is released, the contents will be executed. Okay. Perform the exploit in this task. On the target machine, what is the value of the flag that has now been added to the container? Okay, so we I think need to run all of this. So I'm gonna just copy paste so we don't miss anything, but it is best to type so you will remember. So it is saying temp cgrp is already there for me. So I think I did this task before, so for me it is already there. uh, and if I run here, what will happen? Okay, then I will run this command, and then I run this one. And then we are making the exploit as a shell, and then we are reading the contents of a flag and putting it into the exploit. Then we are making our exploit executable, and then at the end we are making a process, right? And then we do the ls. Okay, we move back one directory, ls again. We have flag.txt, so we will just cat it flag.txt, and here is our flag. Awesome. So we are able to perform our task 3. Let's move on to the task 4 here. Hopefully that will be as easy as we are doing here. Okay. Unix sockets 101. One size fits all. When mentioning sockets, you would likely think of sockets in the networking. Of course, well, the concept here is almost the same. Sockets are used to move data between two places or two processes. Unix sockets use the file system to transfer data rather than networking interfaces. This is known as inter-process communication, IPC, and is essential in operating systems because being able to send data between processes is extremely important. Unix sockets are substantially quicker at transferring data than TCP/IP socket. Okay, this is why database technology such as Redis boost such outstanding performance. Okay, I'm using Redis, by the way, and now I know why it is very quick, because they are using sockets internally. Unix sockets also use file system permissions. This is important to remember for next heading. Okay, how does Docker use socket? When interacting with the Docker engine running commands such as docker run, this will be done using a socket. Usually this is done using a Unix socket unless you execute the command to a remote Docker host. We call that Unix sockets use file system permission. This is why you must be a member of the Docker group or root to run Docker commands, as you will need the permission and need the permission to access the socket owned by Docker. So I don't know if you need to run this command, but let's see. Groups. Okay, so we are in the root group, as you can see, but for him it is cementing sudo docker. Okay, finding Docker socket in a container. Remember, containers interact with the host operating system using the Docker engine and therefore have access to a Docker socket. This socket named docker.sock will be mounted in the container. The location of this varies by operating system and the container is running, so you would want to find it. However, in this example, the container runs Ubuntu 18.04, meaning the docker.sock is located in the var run. This location can vary based on the operating system and can even be manually set by the developer at the runtime of the container. Okay, let's see what happens if we execute this command. And I will grip this sock. I don't have anything here, so I don't know. I mean, do we need to do something here? Exploiting the Docker socket in a container. First, let's confirm we can execute Docker commands. You will either need to be a root on the container or have the Docker group permissions as a lower privileged user. Let's break down the vulnerability here. once we type the groups, we already have root privileges here. Okay, let's see what we need to do. We'll use Docker to create a new container and mount the host file system into this new container. Then we are going to access the new container and look at the host file system. Our final command will look like this: docker run -v, and then we are mounting, and then the rm, and then interactive mode, and alpine, and ch root, and then mount again, and sh, which does the following. We'll need to upload a docker image for this room. I have provided this on the VM. It is called alpine. The alpine distribution is not a necessity, but it is extremely lightweight and will blend in a lot better. To avoid detection, it is best to use an image that is already present in the system. Otherwise, you will have to upload this yourself. Okay, we'll use docker run to start the new container and mount the host file system to mount in the new container. Docker run, then we'll mount it. Okay, we'll tell the container to run interactively so that we can execute command in the new container in it. Now we will use the already provided alpine image. Alpine, we'll use ch root to change the root directory of the container to be mnt, where we are mounting the files from the host operating system. Okay, now we will tell the container to run sh to gain a shell and execute commands in the container sh. You may need to control C to cancel the exploit once or twice for this vulnerability to work. But as you can see below, we have successfully mounted the host operating system's file system into the new Alpine container. Verify success. Okay, after executing the command, we should see that we have been placed into a new container. Remember, we mounted the host file system to mount and then use ch root to make the containers mount become root. So let's see the contents of root by using the ls, this one. Okay. Name the directory path which contains the docker.sock file on the container. I don't know. This is default location for Ubuntu 18.0. Okay, so it is, I think, war run. War run. Yeah, okay. Perform the exploit in the stars on the target machine. What is the value of flag located at root flag on the host operating system? Okay. So let's see if we have Docker. Yeah, we have Docker here. So do we have Alpine somewhere? I'm not sure. Just a moment. Let me see. Tools. I think we need to do everything on the container itself, right? So let's execute this command first. Okay. So it is docker run -v. We will mount mnt rm .itl pine ch root and then mntsh. Okay, ls. We have done so. We have done it. Okay, so ls root, we have this one. Docker.sock file. Okay. We don't have any flag here, right? Okay, wait. Cat root flag.txt. Yay, we got it. Awesome. So we have completed task 4. So thank you very much for joining me on this journey. It helps me a lot if you subscribe, and if you have any suggestion, please put it in the comments down below. Once we come back, we will start task 5 and 6, and hopefully we'll be done in the next video. I hope you enjoyed this video. Please subscribe and give it a thumbs up, and I will see you in the next video. Make sure to come back tomorrow. Bye.